It's funny. Have you ever thought about how even the simplest shapes we draw, like a basic X, are actually following a secret set of rules? Well, today, we're going to be detectives. We're going to uncover the predictable logic that's been hiding in plain sight. So let's start with our central mystery.
Okay, so you look at this, right? At first glance, it's just two straight lines crossing. But this simple shape is actually a perfectly balanced system. And here's the puzzle for us today. If we only know the size of this one angle, can we figure out all the others? The answer is absolutely yes. And it only takes a couple of simple keys to unlock the whole thing.
To crack this puzzle, we're going to need our first key. We'll call it the mirror rule. And it's pretty much what it sounds like. It's all about this really simple, intuitive idea. What you see on one side is a perfect reflection of what's on the other.
Now, if you want the official geometry term, these are called vertical angles. All that means is they're the angles directly opposite each other when two lines cross. But here's the crucial part, the real secret. They are always equal. I mean always, no exceptions.
Just think of that point in the middle as the center of a mirror. The angle on one side is a perfect reflection of the angle on the other. You could even call them identical twins. So what does that mean? It means if you know one, bam, you instantly know the other one. It's that easy.
Okay, so the mirror rule has us covered for opposite angles. Great. But what about the angles that are neighbors? The ones sitting right next to each other. For those, we need our second key, the straight line rule. And it's all about the shape they create together. The official name for these neighboring angles is supplementary angles, and their whole secret is tied to the shape they make together, a perfectly straight line. And in the world of geometry, here's a golden rule. A straight line always measures 180 degrees. Always.
The logic here is super visual and easy to follow. First, you just spot two angles that are neighbors. Then, you notice how their outside edges fit together to form one single unbroken line. And since we know a straight line is always 180 degrees, well, then those two angles just have to add up to that number.
All right, let's recap. We have our two master keys in hand. We've got the mirror rule for opposites and the straight line rule for neighbors. With just these two ideas, we are totally ready to tackle our original puzzle and see this logic in action. Let's make this real. No more theories. Here's our challenge again, but this time with a specific number. We've been told that this one angle is exactly 70 degrees. Can we find the other three? You bet we can. So this is our starting point, our one and only clue. One angle is 70 degrees. Now I know it might seem like just one tiny piece of a four-part puzzle, but trust me, it's literally all we need. Let's go ahead and put our first key to use. First up, let's use our mirror rule. The angle directly opposite our 70-degree angle has to be its perfect mirror image, right? So that means it must also be 70 degrees. And just like that, with one rule, we're already halfway to solving the puzzle.
Okay, now for the two mystery angles that are left. We can figure them out just by looking at a neighbor. See how this 70-degree angle and the one right next to it are sitting together on a straight line? That's our big cue. Time to use the second key, the straight line rule.
We know that two neighbors have to add up to 180 degrees. So if one of them is 70, the other one has to be whatever's left. It's simple subtraction. 180 minus 70 leaves us with 110 degrees. And there we go, we've found our third angle. And from here, the puzzle basically solves itself. I mean, think about it. If that angle is 110 degrees, what's the angle opposite it gonna be? You already know this. Thanks to the mirror rule, it's also 110 degrees. And there you have it. We started with just one number, and we uncovered all four. It's a perfect logical system. You see, the real trick here is just learning to spot the visual cues, like that mirror image or that straight line. And the same kind of visual logic applies all over the place in geometry. So, hey, let me give you a quick bonus key for another super common shape you'll see everywhere. These are called complementary angles. Now, instead of forming a straight line, these are neighbors that form a perfect 90-degree corner, like the corner of a square or a book. And for them, the magic number is always 90. So here's the simplest way to remember the difference. If you see a straight line, your brain should go supplementary and think 180 degrees. If you see a square corner, you think complementary and 90 degrees. It's all about recognizing the visual cue to know which rule to apply. So why does any of this matter? Because these aren't just abstract rules in some dusty old math textbook. No way! They are the invisible blueprints of our world. Seriously,
Structural engineers rely on these exact principles to make sure buildings are stable. City planners use them to design road intersections that actually work. This logic is truly everywhere you look.
So, to recap, you're now armed with 3 powerful puzzle-solving keys for geometry. You've got the mirror rule for opposites, the straight line rule for neighbors on a line, and the corner rule for neighbors in a corner. And the cool thing is, once you start looking for them, I promise you'll start to see these patterns absolutely everywhere.
And that brings us to the final thought I want to leave you with. Now that you've been let in on the secret, you have the keys to unlock these simple geometric puzzles. So the next time you're out and about, I want you to look at the intersections on a map, the frame of a window, or the design on a floor tile. Where will you spot these hidden rules in action?